Right then, time for some solutions to momentum questions 1 to 5. So number 1, we're given a mass and a velocity, and that gives us 20 kilograms meters per second, and from the question diagram you can tell the direction is to the right. 1b, P for momentum equals mv, mass times velocity. Again, 20 times 25 equals a 500 kilograms meters per second, and from the direction in the diagram in the question it's downwards. And part C, P for momentum equals mv equals 6 times 1.5 equals 9.0 kilograms meters per second, and the direction is to the left according to the diagram in the question. Number 2, we are given M1 is 2 kilograms, U1 is 1.5 meters per second, M2 is 2 kilograms, and a U2 is 0 meters per second. So we write down our, in the absence of external forces, total momentum before collision equals total momentum after collision, and then we pick which version of the equation sits best with the scenario that we're given. And that would be M1 U1 plus M2 U2 equals M1 plus M2 times V, because they stick together after the collision. So 2 times 1.5 plus 2 times 0 equals 4V, which means 3 plus 0 equals 4V, which means V must equal 0.75 meters per second. Part B, kinetic energy before the collision is a half M1 U1 squared plus a half M2 U2 squared, which is going to be a half times 2 times 1.5 squared plus a half times 2 times 0 squared. That bit will be easy, and that should give you 2.25 joules of energy. And then the kinetic energy after the collision equals a half M1 V1 squared plus a half M2 V2 squared, which will be a half, well, we can shotgun this together because they had the same V, so it's going to be a half of the mass of 4 times the velocity of 0.75 squared equals 1.125 joules. And since these are clearly different, we can now state that collision is inelastic. So for number 3, we seem to have a target and an arrow. The mass of the target is 4 kilograms. The mass of the arrow is 0.1 kilograms. The initial velocity of the target is 0. It's going to make it easier to hit. And the initial velocity of the arrow is 100 meters per second, which is about right for an arrow. So again, in the absence of external forces, total momentum before collision equals total momentum after collision. And then we go MT UT, because the arrow is separate from the target to begin with, and then it hits the target, so it must be another one of these ones where they start separately and they end up stuck together. So 4.0 times 0, that bit's easy, 0. 0.1 times 100, that's 10, equals a 4.0 plus 0.1 times V, so that's going to equal 1v, so V will equal 10 divided by 4.1, which is 2.4 meters per second, like so. For number 4, then we're given M1 is 2.0 kilograms, U1 is 0.5 meters per second, M2 seems to be what we're trying to find out, U2 is 0, and V is 0.2 meters per second. So another one where they stick together. In the absence of external forces, total momentum before collision equals total momentum after collision. Remember to write that down if you're doing this in the exam. M1 U1 plus M2 U2 equals M1 plus M2 V 2.0 times 0.5 plus M2 times 0 equals 2.0 plus M2 times 0.2, so that's going to be 1.0 plus 0 equals a 0.4 plus a 0.2 M2, which means a 1.0 minus 0.4 equals 0.2 M2, which means that M2 equals 0.6 over 0.2 equals 3 kilograms. And there we go, there's the mass done. Okay, and now for number 5, we have got two masses, 1 kilogram and 300 grams. The initial velocity of the 1 kilogram mass is 2 meters per second. The initial velocity of the 300 gram mass is 0 meters per second. The final velocity of the 1 kilogram mass is 1.2 meters per second. And it looks like we're trying to find out the final velocity of the 300 gram mass. And since these are at least suggested not to be the same number, that means they don't stick together after the collision, or at least we're going to need to use that version of the equation to get the answer. So let's get that down. Remember, if you're doing it in an exam, you've written total momentum before collision equals total momentum after collision in the absence of external forces, just to prove to the examiner that you do know what you're talking about. So there we go, put the formula down and plug the numbers in. 1.0 times 2.0 plus 0.3 times 0 equals 1.0 times 1.2 plus 0.3 times V2. So that's going to give us on the left hand side 2.0 and on the right hand side 1.2 plus 0.3 V2. And then that's going to be V2 equals a 0.8 over 0.3. I've skipped some algebra there, but by this stage it should be obvious how that's happened. 2.67 meters per second. There we go. And for part B, is it inelastic or is it elastic? Well, we need to work out kinetic energy before. So that's a half m1 u1 squared plus a half m2 u2 squared. Plug the numbers in. A half times 1.0 times 2.0 squared plus a half times 0.3 times 0 squared, so that's just going to be 0. That's going to equal 2 joules altogether. Kinetic energy afterwards, a half m1 v1 squared plus a half m2 v2 squared. Plugging the numbers in, a half times 1.0 times 1.2 squared plus a half times 0.3 times 2.67 squared equals a 1.79 joules, if you don't make any boo-boos in the calculator. So since 0.21 joules of EK is lost in inelastic collision. And that's number 5 done.